All right, so power series. So question number one, what is a power series? Okay. This is something that you're gonna have to really pay attention to, because it's we throw variables in. Okay, power series have variables and have something called an interval or radius of convergence. All right, so as the x value changes, the convergence of the series will change. So here's an example of a power series. Okay.
One white, two.
Okay, there's the general form of the power series. Some example. Wait, hold on, that's not right. Something's not right here. I'm in the wrong section. Let me backtrack. Okay, yes, power series. That's the general form of a power series. Okay. Does it look kind of familiar? There's a polynomial we studied that looks kind of like this. Taylor polynomials. If we're headed towards Taylor series next section, which is what these are going to kind of look like. So a power series is kind of a precursor to a Taylor series, which is based on Taylor polynomials. So we're going to combine all that stuff Friday and Tuesday of next week. So this is what there's going to be a number here. That will be the center, and just like a Taylor polynomial, right? And then this is some sequence that will plug in there. That's the sequence. So if I were to fully expand out a power series, it might look something like this, just to give you an idea. I'm not going to make this up because I know all this is it. Okay, so that would be the expansion of a possible power series, right? Can you write that as a series in series notation? Testing your skills. Okay, we know this is going to be centered at 2, correct? What's the exponent on the first one? 0 power, right? So we're probably going to go from 0 to infinity. The first exponent is 0, so that's a 1, correct? Ooh. So how are we going to take care of that? Should we do it differently?
You could just make it really factorial.
N equals 1 and then n minus 1. That's all the issue.
Okay, that solves that issue, but what about the first number?
Make it in.
But that would be a 2 then.
Or n equals 0 and n, you just do factorial. No, it worked for those 3.
It would work for those 3. Okay. And without further information, that is actually correct, right? Because 0 factorial is 1. Thank you, AD statistics students, for that. Okay, so here's an example of a power series. You have your center at 2, and then your sequence n factorial, and it goes on. Okay. we are going to have, I'm going to show you an example of how to see where this converges. And then I'm going to show you what that actually means. Okay? So here is a series that is a power series. Where does, so this is where they kind of change language a little bit. So where does a series x to the n over 2 to the n converge? And we're going through our series tests.
Yeah, I think that's two.
Well,
That's even worse.
are you done? Throw something at you. Jerk. My inability to write is affecting your education. Okay, we're going through our checklists, right? Can I use P-series, geometric series, any of these series, ratio
You
tests,
can use-
root tests?
The one,
What do you mean?
you can take in out and you can do the square root in.
There's an X in it. Geometric series have X's in them. Okay, so good thought, I would have thought the same thing, because it's one half to the end.
Square root
And you would say, yeah, it converges, but what X value does it converge at? Okay, and actually, we might see that that'll work here in a bit, because I hadn't thought of that, we'll see. Y'all see what you say?
The root test. Then you can take out n, and plot in, and you get x over 2. Then you can do the limit as x equals 3.
What is the condition of the root test?
That it has.
It has to be less than 1. Okay, so that's where this is going to be key. I think we can use the root test here. So, is the limit as n approaches infinity of the nth root of x over 2 to the n, correct? So what does that give us? Is that something that we can converge to? The root test says it has to be less than 1. Is that less than 1? Okay, it doesn't give us an answer yet, right? Nope, there's no n in here. N and x, so be careful on these. N and x are not the same. This is our answer to the limit. We have to have, is this absolute value?
Yeah.
It doesn't matter in this case, but for this to converge, that has to be true, right? The root test says the answer to the limit has to be less than 1.
Before that, that's has to be between.
So what
2
does
and
x have to be less than?
2. And because the absolute value negative. Yes or no?
Yes.
Okay.
So what that means is we have a number line here. Any number in here for x means this converges.
So that's the interval where,
This is called the radius of convergence. Okay,
So that's kind of the domain of the graph.
some people will call it the interval of convergence. Okay. The question is, and it diverges out here. This is where these get a little tedious. What happens at 2? and -2. Right. It means it's 1 and the root test is inconclusive, correct? So we actually have to test it. Okay. So we have to test the endpoints.
It's not equal to.
Okay. So if x is 2, the series is now correct,
Which is 1.
which diverges because it's 1 plus 1 plus 1 plus 1 plus 1, right? Okay, so it diverges at 2, correct? What does it happen? What happens at -2? I like to write these out so I can see them.
You get 1 minus 1 plus 1 minus 1 plus 1.
Does that diverge or converge? It does. Okay. So
It diverges.
it diverges. All right, so at the endpoints, it does not converge. So this is actually our true the radius of convergence. Okay. So, that right there, that would be your answer. And this is all your evidence, right? If you're asked to justify your answer, all your work's there, you should be good. Okay, so root test perfectly okay on that one. You said geometric,
They're gonna X be the same.
So,
as
let's-
X over 1
right? What does x over 2 have to be? Is it less than 1? Does it converge?
Yeah.
So this is geometric. I think, you see the problem? You're not gonna get the negatives here. It has to be an absolute value, right? I'm trying to remember the geometric series, absolute value of r has to be less than 1.
Yeah, because the R has to be greater than -1.
Right, yep. So this would still work, right? Okay, so the geometric series tests work. Is there another series test that would work? The answer is yes. Can you think of it? The ratio test. The ratio test is the one the book uses. So if you want to look at that, you can. So you have 3 different possibilities for this one. Okay, to show the radius of convergence. Personally, you want to use the easy one, right? Go that route if you can. If not, ratio and root tests work as well. All right. So, so power series, you got an X in there now, and that as that X changes, the series can change it, whether it converges or diverges. Let's see. Here's another one. Where does the series n equals 1 to infinity to -1 to the n toward the n times n x minus 5 the n on true power series, right? Scripted. And it's an alternating, yes. A little nasty here, aren't we?
So what happens if it converges absolutely and conditionally, how would that affect the?
These converge absolutely within the intervals of convergence. Because we're using absolute value. Is that what your question is?
How many converges?
If it diverges, then you can go into saying, well, it can conditionally converge on this, maybe this interval. We'll see if that pops up. I don't think it will. But, this is a good one for the ratio test. Don't think the root test would bear much. It might work. It might work. But what is the ratio test? Right? It's a ratio test, so it's going to be a little messy, but again, it's just that algebraic simplification of exponents on the top. They get a little messy. Now, some of you are probably pretty good at flipping that fraction over already. If you want to, I'll just do it on the bottom as is.
If you get rid of negative one,
Yeah, that's what we'll do. So the negatives no longer matter, right? Because the absolute value, these can go bye-bye. That's what's really nice here. Copy dot flip here. Copy that. And then flip the bottom. Half of this challenge of these problems is keeping organized and keeping it straight, right? Okay. What can we get rid of here? Oh, we can get rid of this. And what's left here? Just an x minus 5, right? One of them, because the m's are gone, there's one left.
You could do the 4 in.
This is a 4,
And a
right?
4.
What about these two? The ends cannot cancel in this case. Can they? So let's rewrite it, and I think you'll see. X minus 5 times n, 4 times n plus 1. Now we're in an infinite limit. What do those n's become? 1, right? If I had done this, what would your infinite limit be? 1, correct? Yeah, so those become 1, and the answer is x minus 5 over 4.
Oh.
But it's, again, 2 bars. You got that, how we did that limit there? Now, what does this have to be less than to converge? 1, so we're gonna do so multiply by 4, subtract 5. So So we have at least part of our interval, the radius of convergence, right? Now we have to test the endpoints. And I know a lot of you are going to want a shortcut on your work on this. I want to encourage you to do that. Write this kind of thing every time, because that's that memorization thing. And once you do it enough, it becomes automatic where the AP test is automatic. So what are we testing? 9? All right, so what if I write 9 in there? That could be 9 minus 5 is another 4 to the end. How about that? Right? So what is that series do? It's an alternating harmonic series. Anybody? What test can we use?
Root.
No. There's no exponent on the bottom. What's the alternating series test? Yeah, we can use the alternating series test. What does that tell us? To use 1 over n, right? So we can analyze it. I'll use that wording here. You guys have your cheat sheets with you? Alternating series test. It's decreasing, correct? Each term is smaller than the next, or yeah, each next term is smaller, so that's true. If one half, 1/3, 1/4, 1/5, etc. Correct? That's 1 over n. Does the limit of 1 over n equal 0? Limit as n approaches infinity of 1 over n equals 0. Okay, so we've met the conditions of the alternating series test. So it's decreasing terms, and then the limit as n approaches infinity of 1 over n is 0. So it converges. Are you with me there? So I just tested the alternating series with the alternating series test. It's on your sheet. That's what I was looking right off. What about negative nothing? Holy cow. That's a mess. Any ideas? No, hold on, something's not right here. Did we do this right?
Could you do,
This something's not right here. I just followed John Smith's advice and I think we failed a little bit. So I can multiply the 4 out, correct? Positive.
side?
But what do I have to do to solve absolute values?
Could you do -5?
What am I?
Yeah, maybe.
Remember, one of them's the original,
Oh,
right? The other one is times the negative. That means you have to flip this sign. So it's actually going to be 9 and 1. This actually needs to be a 1. Come on, Smith. What'd you mislead us like that for? I should have called it 2. 1 minus 5 is -4. That looks a little more friendly. Yeah? Any ideas? Can you rewrite it somehow?
Well, that's the negative one and -4.
Yeah, they do. And then the 4s then will be 4 over n, 4 over n, they cancel, so what happens is the harmonic series. So you really have to use like one test to get the radius of convergence, then we use a different test for that endpoint and a different test for this endpoint. That's 3 of them. They can get a little bit tedious, right? So it's work, but again, do it right, do it structured, get that in your brains, okay? So what's the radius of convergence, the official radius of convergence is that interval there. Okay. So remember, this is open, so that means it diverges at 1, closed at 9, converges at 9. Do you want to see one more? I've got example 3 here. Do you think you can handle it? It's another ratio test. It's the same procedure. But it shows you different results, so I'm not asking. Where does this converge? Ratio test. A little messy there. Oh, I don't know. Why do I do stuff like that? Eraser. My hand does not listen to my brain. My brain does not. Is that better? And I already copied out flipped here. Is that okay? So I didn't write it as a fraction. I just automatically wrote it. Fine. Okay, so this is x to the 2n plus 2 times
You can
2n.
cross out the x. Oh, yeah.
This is 2n plus 2 factorial. Oh, this is going to fall out nicely. Okay. Yep. The key here is knowing what to do with this factorial. Okay. You've got to think about what does a factorial mean. So if I have, first of all, x to the 2n plus 2, what's left over? X squared, okay? How can I rewrite this?
2n factorial times 2n plus 1 times 2n plus
See what you did there? 2n factorial is everything beneath it. But then you have a plus 1 and a plus 2 to take care of the rest of it. So these are the same statement. Okay. Now, obviously, we're good to go here. And what is that limit? If I put infinity on the bottom, it's going to be 0, right? What does that tell us?
It does convert.
It converges because it's less than 1, right? Okay, so it converges. What's the radius of convergence? Any ideas? Are there any values that we're restricting it on? X is not less than anything or greater than or anything, so what would you think?
All real.
All real numbers. Yeah. So you can write it a number of ways. The book, I think, writes it that way. You could probably get away with that. That's the real numbers. So you could probably write it like this if you wish. The point being, it gives you no x values and it converges, so we know it converges on all x values. Good?
No, I really don't think how we split this with factorial.
Yeah, that's tough
Okay.
algebra.
What is the
But I mean,
factorial? Okay, what is 5 factorial?
5 times 4 times 3 times 2.
Right? So what would n factorial be? It could be n times n minus 1, right? N minus 2 all the way to it's in, right? Does that make sense? Okay, so if we split up 2n plus 2 factorials, we have the first term is 2n plus 2. The next one is minus 1, correct? So 2n plus 1. And then minus another one, and then minus another one. Right? So we have these two. What's the rest of this? That's a 2n factorial. That's how you can denote that. Does that make sense? Doesn't look like you see in your eyes. I'll have to come visit you. Do the rest of you understand it? You're good?
Did you try to figure out?
So basically what you're looking at is subtracting 1 every time you go down a term. So I could write this one, 5 times 4 times 3 factorial, would you agree? Because 3 factorial is 3, 2, and 1.
That's it down.
Yeah, so that's what I did here. This and everything below it is another factorial.
Okay.
The reason you chose 2 in factorial instead of writing this out, so you could cross it out.
Yes. Cross it out. So what's left over? That. I'll come see if you need more help. Okay. This is due Friday, so you have some time. No ones. That applies to you too. Simply known as.
do it.
It's actually,
I was very picky
I just saw
on the problems here, so,
I don't know why.
if you do 3 a night, you're good to go. That's about what it amounts to in the exercises.
That's awesome.
I mean, there were a couple problems that I did on my paper that I didn't end up giving you, so. Well, an APA 3 and 10. Okay, good to go. Got about 5, 7 minutes. Give a couple of those a try. Let me know if you have any questions. You should have some time tomorrow as well.